Okay, let's get started. So today we've got two things on the agenda. We're going to see a nice, really cool example about loading images in and supporting files that work with iPhone, iPad applications. And then we're going to go backwards and revisit the concept of Objective-C, because a lot of students have been telling me that they can't write the code because they don't know Objective-C. And actually I'm kind of seeing I can only go so far in my examples because at one particular point I get stuck because it's too much code. And anyway, long story short, so we're going to start in with some Objective-C programming stuff as well. But I'd like to show you the fun example first. So if you go into the iPhone application development directory and you go under example projects, I've gone away with PowerPoint. This isn't a text file. In fact, I just uploaded it seconds ago. ScrollView, so it's going to be a ScrollView example. And you click on it and you'll see a text file. And so I'm going to just kind of run through this right now, kind of show you what this does, and kind of use this as our playtime for today in terms of our examples. So let me close this. And let me close this. So let me show you the finished product so you see what it is we're building. So I actually created it here so I didn't have to mess around with it. What does ScrollView do? We're going to take 3 images. In fact, I can probably load more than 3. We can load as many as we want, actually, into an app, and the app is going to allow us to go from one image to the other image to the other image. And how's that done? Well, it's done using a special kind of view called a UI scroll view. And the scroll view, and there's nothing better than a demonstration of it to show you what I'm talking about. And let's see. This works. This would work on any type of iPad or iPhone project. Here we go. This is the first image. I wonder why that came up. Interesting. The scroll is this scroll on the bottom. So this is really image number 1, and I know I couldn't come up with any better images. Image number 2, and then image number 3. That might look familiar, but it's all stretched out. And obviously the dimensions aren't really customized, but what we have here is image number 1, image number 2, and image number 3 that I downloaded just because I was not very creative. I just downloaded them from the internet, and I'm going to use them for this sample. But you know, you could pull images, let's say for example, from your photo album. You can pull them from, you know, something you want to show, you know, a demonstration of some sort. It takes you like 5 minutes to put this application together. It's really easy, actually. So that's the finished product. Hopefully yours will have some better images. So let me stop the simulation and build it. And I'm also testing out a new way of presenting these tutorials, so let's see if this works any better. So I loaded it into a text file with clearly defined steps, and I'm using a text wrangler for this. So step number 1, open up Xcode, create a new project, use automatic reference counting, call the application scrolling image, or anything you want really. So I'm going to start Xcode. And I'm going to create a new application. And in my application, actually I have to slip over to iOS over here. Single view application, still a single view. That's the application type. I'm going to click on next. I call it my images because I'm not very creative. And I'm going to use automatic reference counting. So I'm not going to use a storyboard for this. This is actually all done in one view. So, if I can remember this correctly, yeah, I think it is a couple of views actually. So I'm going to load it to the desktop and press on create. So I have a single view application with a ViewController.xib file that I just created, and here it is here. So very good. So now I'm going to go back to my instructions. Xcode automatically creates the directory for me, adds the essential frameworks, yada yada, expand the classes out, double click on the ViewController.xib, or click on it once. Click on it once, it brings it up, puts it into the pane. And we're going to load it up, and we're going to drag what's called a scroll view from the library, and we're going to place it into the window. And then we're going to wire the scroll view to the ViewController.h interface. Alright? So here we are. So I've got the I've clicked on the XIB file, Interface Builder file. I'm going to go to the library down here on the bottom, and there we go. Make it so I can actually see it. I'm going to type in ScrollView, and here's the ScrollView down here on the bottom. And I'm going to make it fill up. You don't actually have to do it, but I'm going to make it fill up the size of the window actually. So now I have a scroll view, and I've got the .h, so I've clicked on the editor in the middle here, so I can bring up the two panes. So I'm looking at what I'm supposed to be doing. I'm going to click on the scroll view. I'm going to press the control button, and I'm dragging it over here. And what do I want to call it? Let's see what I want to call it. Make my life easier. It's going to be called First Scroll View. So I'm going to call it First Scroll View. And so I'm going to go back, and I'm kind of cheating because I looked at the code here of the end result before I did this. First Scroll View. It is of a type scroll view, so I'm going to leave that alone. I'm going to make it strong. Strong essentially versus the other option weak. Strong says don't garbage collect me. Because we have automatic reference counting going on, when we use strong for the property type, and somebody asked me about this, which is why actually it was in the earlier class somebody asked that. Because it's strong, it means it's never going to be garbage collected. The reference count is never going to actually do anything with it. It's going to stick around for the life of the program. Does it really have to? Yeah, kinda. It's actually the basis of our program. So the scroll view is what's giving us the ability to present a continuous flow of information that's going to scroll from page to page to page, regardless of how many images we have in there. So, which is kind of nice, actually. All right, so I have the property in here, and I have it linked. You can see the link here, and I'm just going to look at my code real quick. And this is what my ViewController.h is supposed to look like. So I'm going to kind of compare it here and say, well, I've got the interface, IB outlet, first view controller. All right, looks good. So I'm going to continue. And my instructions say, well, okay, click over. As soon as we add something to the .h file, we're going to add the implementation to the .m file. So out in my .m file, I'm going to go ahead and go back to Xcode here and click on .m. So ViewController.m. I don't actually need this one in here anymore because I'm just going to edit this one, but I'm just going to make this a little bit bigger. There we go. And I've got all of the basic essentials here, but none of the functionality. So I've already got my synthesize here. So I've already got that one. So if I'm going to go back to this file, and this file is the one I just showed you in the beginning, so you can download and do the same thing that I'm going to do, because I'm going to cut and paste it and stick it in there. Then I'll talk about the code. These are the two lines that you're going to see at the top, the synthesize for scroll view, and you're going to see the implementation, essentially, because this is the implementation file, and this is the view controller, and this is going to be the first scroll view. And then what we're going to see down here are some added methods that are going to appear before the view did load. So here's the view did load. So what I'm going to actually do is I'm going to kind of do a cheat sheet here. I'm just going to I'm going to take this out. So I'm just going to delete it. And this is the test to see if this method works a little any better. So I'm going to cut this out here from the text file, copy, and then I'm going to paste it in here. And then I'm going to go over the code in a few minutes. Make sure you have a line return at the end. And lo and behold, it works, which is fantastic. Okay, so what do we do here? And this is part kind of like I'm going to go over today in terms of Objective-C programming. But I can give you the nutshell version of it right now, because a lot of stuff is just like other programming languages that we've seen so far. We created some constant characters, variables, and one of them is going to be the object height and the object width. So that's why those images were all stretched out. They weren't actually meant to be this way. They're actually smaller. In fact, they're probably like, I don't know, like 20 by 20 or something in terms of pixel sizes. So I really have them stretched out big here, actually. I also have an NS UI, an integer value that I'm going to use here for the number of images, which is 3. So, which means we're going to have to find 3 images from the internet or from somewhere. I basically put in PNG files. You can actually, it supports GIF files, JPEG files, any type of image, because we're going to load this into an image view. But the image view isn't on our scroll. We just scrolled one item. We just put one item in there. The entire code, believe it or not, is right here. This is the functionality I'm going over. The rest of the code is simply copying the images and putting them in, and I'll show you that in a few minutes, and then compiling and running it. So we can see we're going to dynamically create the image view. We do have an image view. If I come over here and I go over here and I go image view, we have this image view component, but I didn't actually drag it manually and put it on the canvas. The only item I put on the canvas was the UI scroll view. So the example is kind of interesting because it's twofold, because we're programmatically going to add in an image view in the source code. And then we're going to take the image view and put it inside of our UI scroll view. So it basically just shows you another way of creating components and using components. So what do we do here? I've got a UI image view. Here's where I'm creating it. So the layout scroll images, which is going to be the method that's going to be scrolling the images from 1, 2, 3. And actually I can just, maybe just change this one here to 4 if I wanted to, and then find another image and put it in. So it doesn't really matter how many images I put in here. But here's the object type, UI image view, and as a pointer to the object we're going to call it view. And we're going to initialize it to nil, which means it doesn't have anything yet. It's empty. And then creating an NS array, and the array is just like any other type of an array object, where we're going to have an array, we're going to call it subviews. So the first scroll view subview is going to be the object that we're going to run. So we're going to reposition all of the subviews in the horizontal serial fashion to put them inside of the main view, and they're all image views. Which is why I need to kind of like talk about Objective-C code too, in order for you to fully understand what the code is doing. But we're just creating another float variable. Actually, this is going to be our variable that we have up here, our constant variable that we've defined. It's 460 by object height by object width that we're going to use. So we're setting the height and width of the view with those constant values. And we're going to set the current size so it can be scrollable. So we set it to something that is going to be past the bounds of the image window. That way we can scroll from one image to another. Basically what we're going to do is add the images in one after the other in a loop, and then be able to, scroll. So the view itself will expand, and will actually span in both directions. It'll go horizontally or vertically, but we're going to do it vertically, horizontally. And then in the view did load, which is the method that runs essentially when the GUI is actually initialized and the view actually shows up to the user, we're going to set the background color to view flip side by side background color. It's just a way of setting it to the background color of black essentially for the image. Then we have set the background color for black color. Set can cancel content touches, essentially making it so that you can't, if you were using your finger, you can't get out of it. It cancels all of the other activities. Setting some other parameters indicating the style, the clips to bound, setting this scroll enabled to yes, the paging enabled to yes, which are all basic properties that are being set on the scroll view itself. And then here's the meat of the application right here. So for I is equal to 1, I is less than or equal to the number of images. Well, we set the number of images to 3, so we know it's only going to load 3. And a string as image name is going to be equal to, create a new string, and the string is going to hold a wildcard in here, so it's going to be the number I. So we're going to start in with I is equal to 1, so the first image is going to be snap 1, so which is where we get, substitute in the $D, which is the, so if you know about C, it's printf syntax that's in the NSLog. It also works with the NSLog, also works with other string manipulations as we've seen here. For constant character, snap, so we got snap 1, snap 2, snap for all the instances of I up to the maximum of 3. So that's where we get the name of the image. And this is kind of a crude way of doing it, but it's just going to look for the names of the images, right? UI image, well, load the image in. Image name. So UI image, image named, send the parameter of the image name. Well, the image name is the snap 1, snap 2, snap 3. So if you download images that aren't, and I'm not going to give you any, actually I don't give you the complete project, you don't really need it. If I download images that are PNG, change the, or JPEG or something, change the extension. Set the rectangular height and width of scrollable objects. Image view frame is going to be a rectangle in this particular case. So we're just setting a tag to I. So we're starting out with 1, or it's basically going to be tagged, the image name with the image view. And then that's it, actually. At the end we do the did receive. Well, okay, so how do you get the images in? Well, this is the interesting spot. So now I've got a view that's going to programmatically load an image view component inside of it. So here's the thing right here. So I didn't load them in. Okay, then I'm like where are my files? In my supporting files directory, I've put the images on my desktop actually. In fact, I can put different images there too. I'm just going to drag them and stick them in supporting files. I'm going to say copy items into destination folder, yes. Or I could move them. So if you're going to use these images, which I've decided I'm going to use, I'm simply dragging them in. If I look at the directory that is out on my desktop, I just dragged all 3 of them in there. It doesn't really matter what order you drag them in. If you look at the directory structure, you see the 3 images actually in the main folder, which is where they're going to show up. So if you didn't like dragging them into Xcode, you could drag them into the folder directory. That's how you're getting them into the project, actually, because it's just loading them from a command prompt, essentially, taking the file, loading it up, assigning it into an image view controller, image view component, and then making it load automatically. So if I press run here, it should hopefully run the project correctly. Yep, there we go. There's image number 1, there's image number 2, and there's image number 3. So it's actually kind of cool. It's kind of an easy way of programmatically just loading up images and putting them in. So it could be a bunch of pictures. You could put, you know, create an app that says, you know, my vacation photos. I don't know what the sense of that would be, because you would, you know, well, actually, it's a great way of packaging files as well in with the application. So by loading the PNG files in here, I can use them anywhere I wanted to. So I could actually redesign the app to make one of these the background of the window or something, basically. Or I could put audio files in here, video files, PDF files, text files, anything that I wanted to use locally within. And this is very similar to the Android class and putting it in the assets directory or the raw directory for file I/O and stuff like that. So it's the same concept, except for you just putting it into supporting files. You don't actually have to put it here. You can actually load it up into the main directory if you wanted to. If you click on the files, you'll see them actually opening up. So they'll load from anywhere. I didn't set, I believe there's no path generated in the code. Actually, let me just check that real quick. I don't believe that there is a path in the code, which means they're just loading from the current directory. Oops. Nope, there's no path set. It's just the file names that are there. So it's going to look for it in the main directory of the project folder, which is where they're actually located. If I wanted to, I could tweak the size of the images as well, and I can also tweak the size of the scrollable and make, like, say for example, make this only go up halfway or something. If I did that, actually, it would be able to scroll both directions. If I could click on it properly, yep, there it is. I just moved it. Let's see. Oh well. Anyway, to reset. Actually, which is it right there? It's going to be outside of the window. It's not going to work actually. But anyway, hopefully you get the understanding. You can reposition it. It doesn't have to fill up the entire size of the view, although it's nice that it does. It doesn't have to. You can put text on the bottom, you know, subtitles. And the first one, it just keeps scrolling through. Let's say, you know, my vacation photos, you know, my something or other photos. You know, so. Alright, well that was the fun part of today. So, I shouldn't say that. That's a bad prerequisite to the lecture. That was the fun part. Anyway, so I did cover everything in there. That's good. You know, obviously you could play around with it a little bit in terms of the desired functionality. Okay, so here's the bonehead part of today. So I realize a lot of you are just learning Objective-C, and some of you aren't even in the Objective-C class, which is kind of a shame. So to save myself a lot of work, I'm going to go through one of the lectures, and some of the people who are in the Objective-C class aren't going to like this because they've already heard most of this stuff already, because that class is farther ahead than this one, because I'm not trying to teach you iPhone or iPad. So long story short, you're going to be bored. You're not going to offend me if you leave early. No problem. Today and most of Wednesday is going to be about Objective-C, actually. But it might be a nice refresher for some people. What am I going to cover? I'm going to cover, basically, I'm going to kind of skip through this and start right here, actually. This is, just so you know what lecture number this is taken from the Objective-C course, by the way. And it is in the summer 2012 directory under the Object-Oriented Programming in Objective-C. This one is lecture number 1, by the way. I'm not going to go through the whole thing because this really isn't the Objective-C class, but I want to highlight it and you kind of use it as a visual aid to gear the content that I'm going to present in a certain direction. Okay, so we know we're working with objects. This is just like object-oriented programming in any other language. So we know that Objective-C, hopefully at this point, is written on top of C, is a dialect of C. Just the same way C++ is a dialect of C. All the same concepts of C++ are there, plus Smalltalk. And I'll tell you what Smalltalk and which of C++. You can probably identify all of the C++ stuff on your own, especially if you have a background in it. If you have a background in any other language like Java, as an example, works in replacement of C, because C and Java, in terms of the syntax of variables and stuff like that, are almost, there's a lot of similarities in it as well, so you don't actually have to go back and take a full C course at this point, hopefully, if you've got any other language under. We still have methods, we still have instance variables. Interesting, however, in fact, you know what, I'm going to bring up Hello World, because I want to show you something. Let me bring up Hello World. You can bring up a Hello World. So now we're not going to look at the iOS stuff. I'm going to look at OS X application and command line tools. And I'm going to create Hello World for Objective-C. And I want to show you something because it kind of merits a little discussion, and I like to kind of customize this particular lecture so it's not as a repeat of what you may have already gotten in the other class. If you bring up a standard old project, like I just did a few minutes ago, instead of clicking on the iPhone, iPad, you're going to see up here on the top, Mac 64-bit. Okay, it's the same language that we're going to use to create objects for iPhone or iPad as we're using for Objective-C, for Coca interface, for the Mac operating system. So this is Hello World, actually. And if I run it, what I'm going to end up getting, and this is the great way to learning Objective-C, is to look at Hello World, actually. What I get on the bottom of the screen is Hello World. Where did I get that from? Because I'm not working with an iPhone or an iPad. I'm printing out an NSLog, and NSLog is equivalent to printf, actually. So if I did this here, I can go like this, actually. I can go printf. This is to show you how similar C is to Objective-C. Hello from C with a question mark. I've accomplished the same task, actually. If I run it, I get hello from C. No, this is Objective-C, it's not C. That's why I put the question mark there. And as we saw earlier in today's class from the iPhone class, excuse me, from the Objective-C class, out here I can go integer I, alright, and then down here in the bottom I can say scanf, let's see, I, well, I can go D here, or I, and I can go the address of I, and I can go, well, what does that mean? Well, actually, let me make something a little bit more meaningful. Enter an integer. And then it's going to enter in something, and then we can go printf. I'm going to explain the code in a few minutes. You entered you entered, let's see, D, I. Okay, so what did I do here? What did I do here? This is normal functionality that's usually included in iOS. If I were really to write this into a C program, I can go like this actually. Include, what is it? iostream, no, stdios.h. There we go. I don't actually have to do that because it's included automatically. But this is a C program without the auto release pool. But I'm going to take this out because I don't, you know. We can use import or we can use include, which is both. If you're using C, you're familiar with include. If you're on Objective-C and this is your first language and you don't know C, use import because you're not going to make it. They both do the same thing, except for include will include it, whether it's there or not. Import will put it in if it's not there. So one of them is more efficient. Actually, import's a little bit more efficient. We can actually do this if we wanted to. Import, that works just fine as well. But the includes and the imports are identical in terms of your usage. It just means something a little bit different. We're going to basically be more efficient by not including it if it's already in there. So we don't get remember that problem with multiple includes? You don't get that if you're familiar with the in definition of C, C++. Not a problem. Because if it's there, we include it. If it's not there, I mean, if it's already there, we don't try to include it again if we're importing. But if you didn't understand any of that, don't worry about it. Just use import. Import's going to import libraries. And Foundation is the library that we're going to use for that Coca interface. So main is main. Same main we got in C. This is the same. This is different. This is because we've selected auto reference counting. And this is the way to go, actually. You encompass the entire program inside of auto release pool, which basically says do our own reference, do the reference counting for me. I'm going to allocate. I'm never going to deallocate anything. I'm not going to tell you to retain anything. I'm not going to do anything. And you're going to automatically, because you're intelligent enough, you're going to automatically do everything for me. Which is like, this is like the cheat sheet way of not having to learn anything about memory. We still have pointers, however. This is actually coming from a pointer perspective. That says the address of I. Scanf actually takes on a pointer. I can mix and match. I can create an object like NSString. And I can say, and if I do NSString as a data type, I have to actually preface that with a pointer symbol and say my name if I'm going to do that. In fact, I'm not going to do it in here actually because this is wrong syntax, wrong place to put it. But I'll talk about that in a few minutes. But it would actually go out into an object inside of one of our class files. So we have this really nice program. I was like, okay, great, does a lot, right? Well, okay, so it doesn't really do that much for us. If we run it, I didn't run my other one here. We can see it actually works. So we say enter a number. I'm going to put in here 56. You entered 56. So we have like standard basic I/O, very similar to C. And we also have very similar to Java kind of, but very, very small talk like syntax for objects. So I'm going to go ahead and create an object in this project. So same as the Java course when I said we have a driver program and our driver program in here is main. We don't actually have to create a separate object for it. We get it automatically with the default project. So if I go File, New, and I create another file, and I'm going to call this an Objective-C class. Same thing when we do with the iPhone, but I'm going to do it over here because I'm in a Coca application right now. And I'm going to say next. And I'm going to call this one, what did I do in the other class? Person or something? Or, I don't know. I don't want to do the same example again. Let's call this one date. Make it a date. Date class. So we get hours, minutes, and seconds, so we can store in here. And you notice we have two sets of corresponding files. Same thing as we're doing before, but we have the interface date that, in our particular case, because we're in a foundation libraries and we're working with Objective-C on a Mac, we're inheriting from NSObject. So we're not going from NSView or ViewController or some of the other things. But same concept, however. And then we have the implementation of date. So to compare this with Java a little bit, the structure is kind of the same, except for instead of saying class, date, extends, NSObject, and we have those opening and closing brackets. In our particular date class, we're going to put the variables here at the top. And this is the same for iPhone. This is the way you're going to create the class modules, so, or the objects for the implementation of classes. So here I'm going to have an integer day, yeah, integer month, integer year, you know. But that's the only thing that's actually going inside of the opening and closing brackets, where in Java everything kind of went inside, and in C++ everything goes inside the opening and closing brackets. And then our methods go outside of the opening and closing brackets. And because this is a function prototype, excuse me, this is a interface, we define the data in the interface and then we use it. So I can put in here an NSObject and stuff as well. So I can combine, I'm not just looking at C right now to make things simple, but we can have object declarations, we can have variable declarations. I just did 3 integers. Obviously there's other data types we can put in here as well. Outside of here we know we have pluses and minus for methods. Minuses are instance methods. So I can go here. This is the small talk part. So if I were in C, or if I were in Java as an example, and I wanted to do a method, and I wanted to call the method, get date, and it's going to return an integer value. It's a get day. How about get day? That works. I'd go like this. This is the syntax. It's not going to work. It's going to give me error messages, but this is the syntax I would use. I would go get date, and then I'd have like, you know, well, that would be like the function. And then that's going to give me, well, actually, it should give me, it's just taking it okay. In Objective-C, we have slightly different format. We go a minus sign, we put the data type inside of quotes, and then we give it the method name, like that. So that's the correct syntax. I'm surprised that actually, you know what, you can, that was C++ prototype, it works actually. You don't want to do that though. And you want to type, you don't want to program in C for the rest of your life. You want to do Objective-C if you're going to do this. That syntax didn't give me an error message because it'll accept it. It's C equivalent. But that would be considered the function prototype. And then over here in main, I would have another function out here, oops, excuse me, over here in the implementation file, the .m file. And it's going to give me an error, it's going to give me a warning here and say, incomplete implementation, yeah, because I don't have this guy defined. So so I don't have to type, I'm just going to copy it. I'm going to go over to date, and I'm going to put it in here and paste it, right? And it's going to say, well, don't put the function prototype in there, put the implementation in there. So I have to return a value because this is an integer. Return 0. There we go. Actually, let's just return date. How's that? Return day. There we go. And now I've basically created a method called getDate. Then we have this little thing called property and synthesize, which is an automation approach to this entire concept. And I know I'm kind of jumping around, but this is stuff that I think is going to be relevant for your iPhone career, your iPhone, iPad development. And then I'll go back and show you the PowerPoints in a few minutes. But most people have problems figuring out, well, where do you put the methods in the code? And what do the methods? Everything you're going to do in these classes is going to have a minus next to it. Minus says this is an instance method. The pluses we're going to see, actually we saw it with the prototype, I believe, or we saw it with categories. Depends on what you're doing with it. A plus, if I were to change, and this will work, the syntax will work just fine. If I go like that, well, it won't work here because I can't, this is, it's going to tell me the scope. Yeah, instance variable day accessed in class method. I just turned this into a class method instead of an instance method. And this is an instance variable, so I can't return it from a class. I can't return it this particular fashion, but if this hadn't been, let's just say return 0 as an example, well, that works just fine. It's a class variable, which means you don't have to make an instance of that particular object to run this method. You can just run the method as if it were a function, which is how most of them are done. But I'm going to put a minus here actually. And then actually I'm going to leave this one. I'm going to call this method here get something. And something is going to return day, because I'm going to show you something else in a few minutes. It's called the property and synthesize. This little warning here actually still shows up, says incomplete implementation, because I haven't created the setters and the getters. So Objective-C follows strict object orientation. Strict object orientation says for each one of the data members that you have, when you have declared them here, these are private data members, and you're going to have public member functions that are going to implement ways of accessing and modifying the private data, because you can't modify this data outside of the class interface. So we have these things called setters and getters, which is why I call them set and get in Java, because it's like set date, set month, get month for each one of them. But what if I don't want to like do that all over again, like 100 times? Well, I can use this thing called property, and I can set properties in here. I can use this here called property. And let's see if I can get the date correct here. Day, comma, month, comma, year. Let's see if I'm going to get a message. Nope, good, I remembered the syntax here. So property, and I gave it the integer as a data type, and then I put them all together on one string here, because I can do that. I can actually just do this if I wanted to instead, which is the same thing. Actually, let's just do it this way. So now I have one on one line and the other on the other line. And I can do the same thing with the synthesize. If I go over here and I go synthesize, let's get rid of this one here. Synthesize property. Synthesize, what was it? Month, day, year? Month, day, year. There we go. Now I've done the setters and the getters for both of them automatically. So I declare the property in the interface, in the .h. I implemented by synthesizing, using the keyword synthesize. I just created I created 6 methods, actually. I just created get month, get day, set day, get year, set year. And I did that in like half the amount of time that it would take me to write 6 methods, which is why I go ahead and do that. I could also put here get month, get date, and if I run that, I can run the method on it. Or I can simply return the value. So it's kind of a seamless kind of approach to it, because when you're out in main, and well, I'm going to make an instance of this object pretty soon here, and when I make an instance of the object, I can just say, you know, give me the month, give me the day, and it'll deliver whatever the month of the day is. So I'm going to say here, get something. Well, you know what, I'm going to create another one here, because we have to set some stuff. And this is going to be kind of a crude implementation, because it's sort of on the fly here. I'm going to say, call this get set something. So I have a method that will basically say set something. Well, what am I going to set? I'm going to hard code this right now, because I don't want to worry about parameter passing, because I'm going to show you that syntax in a few minutes, and I'll use the PowerPoint for that. But let's just say day is equal to 5. And well, no, actually, what is today? Today's the 30th, isn't it? And month is equal to 7. And year is equal to 2012. And this is just going to be void, actually. I'm going to make this void. And so now I've created a method here in terms of in my .m file, and I'm going to put this function prototype actually out here in my .h file, so I don't get any. And I'm surprised that it didn't give me any error messages, which is kind of interesting. There we go. So I have the function prototype for this new method I just created, and what did I do with the other one? I guess I took it out. Oh well. Well, put it back in. Let's see. Get something to copy. Let's put it back in, actually. Let me do this properly. So integer get something and void set something. And the get something is just going to essentially return day. Day is going to be equal to 30. So, all right. So I'm going to make an instance of this object now out in main, and I'm going to run the methods on it. So this is where the weird part starts coming into place. So out here in main, in order for me to see that, I have to import, which is, you know, not the weird part yet. This is just import date.h. So now I've imported it, so I can see it inside. So I'm going to get rid of this code here because I don't really need to worry about printf and scanf anymore. Actually, I'll leave it. Let's just put it underneath here. So now I can actually allocate, when I allocate objects, I'm going to use a slightly different syntax. And let me show you this to you first so you can kind of see what I'm doing. And then I'm going to do it in my example. So I'm going to kind of catch up with the method. I'm going to catch up with the lecture and then go back to the example because it's easier for me to show it to you this way. We're going to create instances of these objects. And then we're going to run methods on the instances of the objects. And the methods are the methods and instance variables that are associated with it. So we know about the .m, and we know about this particular one is going to do a list.h and a list.m. I did a date in my example. So I'm going to skip ID for a second. So messages. Messages run in this format. When we make an instance, actually I'm going to skip ahead to the instance of the object first here. Here's the instance of the object. The instance of the object is going to be a data type. So start an object instance. Actually, maybe I'll show you ID here. Let me go back to ID because I'm going to need to skip ahead to the... Okay, ID. What's ID? When we don't know the data type of the object, we can use ID. And we use this a lot actually in the iPhone, iPad environment because we don't necessarily want to have to like keep what data type is that? All these different components, usually GUI components or something. ID says just anything, just reference something. It's kind of a cheat sheet way of making a generic object out of it. Because the language is 100% dynamic, which means everything is allocated dynamically. So the memory is allocated dynamically, the references, the types, everything's dynamic. So ID data type has no information about the object. Every object carries an is-a relationship or instance variable. It's similar to the concept of the object. So if I said use the object data type in Java, it's equivalent to ID. So objects are thus dynamically typed, and they all can be assigned ID as an object type. And so the ID is the data type that's used to define a pointer to an object. Very similar to the objects data. It's sort of like the asterisk in C++, kind of. So people don't like the asterisk because it's a pointer variable. When you use a pointer, all the variables that we declare of object types are using pointers in Objective-C. So you have to use pointers whether you like them or not. So any type of an object, as long as it's an object, can use the ID type. So in this example, we can define an object by going ID space object name. So in this particular example, I would go ID space date. Well, date, my date. How about my date? My date. And we'd be like, well, what's my date? Well, my date is going to tell me it's not used yet, which is what this warning is. Unused variable my date. Well, then my date's going to be equal to something. What's my date going to be equal to? Well, my date is going to be equal to. And then I have to worry, well, how am I going to write the method call? Well, okay, so I have to make a new instance of the object before I can use it. So I have to call alloc, which is the kind of the weird. This is, I said, this is the weird part. This is the odd part that we get. What we don't have in any other language. So normally we would say, you know, if we were in C or C++, we would say, or if we were in Java, we would say, if I was creating in this particular case a rectangle, I'd say my rectangle is equal to the new rectangle or something. I would use new. We don't use new. Instead, we use alloc. And then on top of alloc, we can run init to initialize it. So this is the constructor part of the object. I'm not going to cover constructors. That's why I said this is going to be really a two-part kind of thing. So we have rectangle, alloc. In this particular case, well, alloc is a method. So I don't actually have to run both of these together, and I'm purposely not going to show you that I can simply run date space alloc and assign it to my new object. So the syntax that I'm going to use for this is going to be, well, it's going to be date space alloc. And now I've allocated a new date. But my ID type was my data reference. So this is the reference to the data that I'm gonna, reference to the object that I'm gonna create, which I haven't created yet. So I could do this all in one shot. And I could not use this as a date. I could do this. I can go, excuse me, as an ID, I can go date, my date. That's more common, actually. But in order to do that, we have to allocate the date. So my date is going to be equal to, why do we have this here? We have this interface type cannot be statically, cannot be statically, so I have to put the asterisk in here because I'm creating an object. So this is, what do you call this? This is a reference to a dynamic, because this is a static object that I need to create dynamically. So this is where I said, well, you have to get used to pointers if you're going to do it this way. So if I say, for example, I was going to create an NS object, and I was going to create an NS string, I'd have to go NS string, and then I'd have to use the asterisk here and say my string. Basically, every time I create any, and this is not coming up correctly for some strange reason, but I'll just leave that out of here because I didn't use. Anyway, long story short, this message you can say it's unused. Yep, it's unused. But I have to use a pointer here because I'm not referencing it through a reference object. So I'm going to leave this here for a second and repeat what I had up there a few minutes ago. I'm going to say ID, another date. That's a reference to the object, and ID is a generic object reference type, which if I did this, I should get an error. Yeah. What's the error message say? It says pointer to a non-constant type ID with no explicit ownership. Yeah. I can't create a pointer to that. There's not the object doesn't exist. It's just a generic object that we've created, object type. So if I take the asterisk out, ID is almost equivalent to the pointer. This, in fact, this is what you're really typing. But you're using ID instead of the pointer symbol. But you're really creating a reference to an object when you do ID. A lot of people like this because then they don't have to use the pointer. Actually, if I create this correctly, underscore here. There we go. It is case sensitive, by the way. If I do this, then I don't have to use the asterisk, which is what I'm doing here. But I still got to allocate it, and I can allocate it all in one line if I wanted to. I could say, I can still do this. It's equal to date alloc. Oops, if I spelled it correctly, date alloc, which is doing the same thing. Or if I wanted to, I can put this inside of even a bigger, and I can go init. Oops, int, init. And you're wondering, well, I didn't write an init. I didn't write a constructor. Well, this is calling object, NS objects init, initializer. Which means if I wrote an initializer, think of an initializer as a constructor right now, then it would run the constructor for me. It's not going to automatically run it for me, which is what you get in Java. Java's going to automatically run this stuff for you. And you call the constructors with the same name as the class, and you just make a new instance of the object, and all of a sudden you have this new object that's created, and you can pass it parameters and stuff. Here you actually have to explicitly pass it parameters. So here's another thing that you may have noticed. It's a slightly different kind of format. So this is the name of the object, and this is the message we're sending to the object. If I were writing this line of code in Java or C++, and if I was just looking at this part of the code, this would be equivalent to writing date.alloc, which is going to give me an error message. So if I were writing this in Java, I'd say date, my date is equal to new date, date.alloc. If I were writing this in a different language, actually, if this was capitalized, this actually has to be capitalized here. Not going to work. We're going to get a bunch of messages here because this is not Objective-C syntax. But this dot notation that's used here is different than this notation here. This is replacement of it. So instead of saying date.alloc, we're saying run the alloc method on the date. So here's another example. I can go like this and say integer test. Actually, day. Didn't the day function return some day? Dates. Nope, my dates. On my date object, run, what was it, get something? I think it was called get something. Get something. Now, this is going to be equal to 30 because I set the date to 30. And get something, where's get something? Get something is returning day. And if I run this, day, which is not used, well, let me use it here. Then I'll just go like this. I'll go here, print f, because this is an integer. It's not an object. It's not an object. It's an integer. It's a built-in data type. Yeah, it runs the init function. I'm going to talk about those next time, actually, but because constructor creation is going to be way too much for one introduction here. But I'll do it Wednesday. But what we're doing here is actually running a method. So out here, actually, I can write a method, and the method I'm going to write now is going to be called, yeah, init something. How's this? Init something. All I have to do is use the keyword init in there. If I did that, actually, this would work. I can go back up here and say, oops, main. Here we go, main. Init something. And I'm basically running init something. This line of code here's going to give me problems till I finish it. I'll print the day. And then I'm going to put the $D in here. And I'm going to go day. And I'm going to go up here, and this is going to give me an error message. And I'm going to go, why is it giving an error message? Because I'm initializing strong ID with an expression of an incompatible type void. Yes. I didn't do it correctly. No, it's an incompatible type that I'm expressing with an ID. The method call is wrong. But let's see. Let's fix it. That is not going to work until I do this. There we go. And I'm still going to have a message. What's the message? How strong? Okay, this is going to, this I have to show you a little bit slower. If I do this, actually, it won't work because it's going to call the super objects in it. There's a problem with the way I just created that method. But methods that are used as initializers, and they call them initializers instead of constructors. Because you have to, only thing you have to do is start out with the word init. And initializers that start out with, like, initialize something, I should have actually put something in there. Well, it should, like, take properties, but I haven't shown you how to do properties yet. But normally you're going to initialize, you're going to send some information to the objects. And you don't actually have to do that. I don't actually have to do, or I could, you know, come up here and I could put it all in one, or I could run it in two separate calls. Normally I'm going to put it all in one call, though, because I'm going to automate it. I'm going to go like this and go init to initialize it as well as calling it. Actually, what's wrong with this? Probably the syntax. Well, alright, let's just leave this alone. Let's see what happens when I run it, actually. Unused variable. Yes, I know. Print a day, 0, enter an integer. Okay, well, 0 was never initialized, however. We never initialized that object, that instance of that object. So if I did this, integer, let's just go here, day is equal to, let's do this here. Get rid of both messages all in one shot. Get rid of this code here, make this a little cleaner. Empty, yes I know, it's empty. Stop. Oops, probably ran it twice. Unused variable I. Where is I? Oh, here's, why do I have I up here? Let's get rid of I. I initialized it. Oops. No. There's a date, another date, date alloc. Well, I didn't create a constructor to initialize the data, actually. So the data is going to be 0. Because I need to run that function to set it. The data is 0 right now because I have to run set something. So let's run set something here, and I'll show you how you get the method to actually print. It's going to say print the day 0 because print the day value. Make this a little bit more meaningful. And so it's going to print out 0 because it's not initialized. It's 0, which actually kind of shows you another point I forgot to mention. We created these guys up here in the synthesize and in the property, and then I created integer month day year. Property creates the properties for it, initializes a value to 0 if it's a number, or a blank space if it's a character, or a blank string with a null string actually, null object if it's an NS string. So objects will be null, integers will be 0. So if this were a C program and I did that without initializing the value of that, it would print out some garbage to the screen. But it's actually got initialized automatically to 0 because it was an integer value, and this function that I'm running, get something, is printing out get something, is returning the day, but I didn't run set something. So I'm going to run set something, which I should have done first. So let's just run this way. I'm going to go another date, set something. There we go. So you can see I've just basically run the method. I'm not like assigning the method return value to anything. So the same concept actually exists. Like what I'm doing here is taking day and returning this value, because this method get something is returning day. So now we should get 30 printed to the screen because another date running method set something. Sending the message set something to another date is going to initialize in our code day is equal to 30, month is 7, years 2012. So now if I run the example, incomplete. What did I do here? I'm sorry? Oh, you're right. I'm printing out the first one. Hold on. Let me change my code here real quick. Let's just do this one here. I have the printout occurring first. So let's see. What am I printing? Day. Very good. We don't really need that. We don't really need that other object in there either. Here, let's just get rid of it. Make the code a little bit better. So another date. Oh, day. It actually was. What did I delete? Day is equal to my date. Get something. Day, integer day. Let's just do this here. Okay, very good. I don't need this one either. Let's do that. So it should be date. Okay, good. Now let's see what happens now. Yep, now we have 30 printed out to the screen. If I get the order of the print in there correctly, it will print after I said something. I'm hoping you guys followed along with that. So that's just one example of using an object. And the object that I created was date object here. I can create many other objects, and then I can inherit objects from objects as well. But I don't want to get into that till Wednesday. So let me go back to my cheat sheet here. See what I didn't cover. So let me give you this here. So this is the syntax that we're using. The alloc. I'll go back to the slides I skipped in a few minutes. So in this particular case, we're making a new object of the reference type a rectangle, or alloc, and we're creating the object in this particular call, and then in this one we're running init on this result of this object, which is the newly formed object, and we're assigning it all to myRec. myRec is of the type ID. So the alloc method returns a new instance and performs an init method to set its initial state. And I'll show you the initializers on Wednesday. So we're working at polymorphism. We're looking at, let me just make sure I didn't, okay, so we got that far. Are we good on the ID concept of the object? ID is a generic reference type. So ID anything. So nil is a reserved word for null objects, actually. We can make it equal to nil, which means it's null. If we haven't assigned it anything, it's going to be null. ID gives us dynamic typing because at runtime, we can take that ID, my object, and make it a rectangle, make it a date, make it a string, make it anything we want, actually. And every object carries that is a instance to it. So if everything is an ID, everything is an object, all objects are compatible, which leads to polymorphism, actually. Because then you can create functions or methods that pass anything as long as it's an object. So we have dynamic, that's what's referred to as actually dynamically typed language. So this language is dynamically typed. So at runtime it determines what it is. So it can find exact classes an object belongs to by looking at the is a relationship. Okay, so here's your formal message declaration. So messages. This is using instead of the dot notation as I was showing you. So to get an object to do something, you send it a message. It's actually called messages. And this messages comes from Smalltalk. Java calls them methods. We pass method calls and we run methods on objects. So it's the same thing as a method. So telling it to apply a method. So here's the syntax. The receiver object with the message we're sending it. So if we do our message names like get something, set something, run this, run that, we're just basically telling the objects what to do. So we're controlling the objects. The receiver is the object. The message is simply the name of the method and any arguments that are passed to it. I'm going to talk about arguments next. So here's another example of the myRectangle. So I gave the, well, I actually didn't use it. I used the person because person employee, and I can probably go through that when I do inheritance with you on Wednesday. But the message tells the myRectangle object to perform its display method, which causes the rectangle to display itself. Okay, so myRec space display. That's just like saying another date or my date space get something. The C++ equivalent to that is myRec dot display. So this is where that dot notation is coming into place. And then we have myRec set origin. And you're like, okay, this is the new part. So we're running the method and we're sending it now, in this particular case, 2 parameters. Parameters are separated by the colons. And this is confusing because the method doesn't look like this. There's stuff in between. So it has 2 colons, one for each of the arguments, and the colons go right before the arguments. So set origin colon 30.0 space colon 50.0 is equivalent to 30.0 comma 50.0, which is the method call you get. This is C++, it's actually Java as well. You know, I'm not familiar with C++, it's just like Java. That's why when you learn Java, you can learn C++ like that, or vice versa, because the languages are so similar. So the arguments are inserted after the colons, breaking them apart, and you also have to put a space in there as well. And you have, well, excuse me, space in here as well. You have to have the space in there. Polymorphism, so each object has defined its own methods, but for different classes, so they can have the same method name that has totally different meanings associated with it. So we have overriding and overloading. Same thing we looked at in Java that we have in Objective-C. Same concept, implemented the same way, actually. So 2 method objects can respond differently to the same message. So if we had a square dot square, my square display, my rectangle display, it should hopefully respond to the word display, and all of this stuff maybe is inherited from shape, as an example. So So together with dynamic typing, it permits you to write code that might apply to any number of different kinds of objects without having to choose at the time that you're writing the code what object type you're actually using. So in a non-iPhone iPad, we have NSObject, which is the highest of the hierarchy. Because we're not going from views and we're not extending view controllers and things, which are lower in the hierarchy, actually. Because you think about the concept, everybody comes from NSObject. This is kind of like everybody inheriting from object in Java. And then here we have graphic, text, image. Okay, we have shape. From shape, we have a line, rectangle, a circle, and we have a square. So square is really a rectangle, which is a shape, which is a graphic, which is an NSObject. So at any one moment of time, we can take an ID and attach it to anything, and then flip back and forth between the different hierarchical levels of the hierarchy. So in here, this is a cumulative, so a square object down here has the methods of the instance variables defined for a rectangle, graphic, shape, and NSObject, as well as those defined for square. So same as Java, actually. We saw the same thing. We have instance variables. Those were the ones in the date class. I said integer, day, month, and year. Those were called instance variables. Each instance of the object has a separate set of variables. So a new class object contains not only the instance variables, but you can define them for its class, but you can also have instance variables defined for superclasses and all the way back up. So if I made a class extension from date and had my extended date, I would have month, day, and year in there, and then I'd have like area code or something that would come from that. And then methods. So an object has access not only to the methods, but it can be defined for the class, but also from the superclass. So let me just show you real quick what I'm talking about here, because this makes more sense sometimes. I'm going to make another class. I'm going to put a class in here, a new file, and it's going to be called Objective-C class. Okay, good. Coca. Okay, next. I'm going to leave it as a subclass here of NSObject, but I'm going to change the subclass programmatically to show you what this is actually about. I can leave it here, or I can actually do it like this and go date. Because in my project right now, I have a date class, and I'm going to inherit another class from the date class. I'm going to call this time date. I don't know, because I'm going to make up this funny notion of there being a time zone with a date. I don't know. Or I don't know. Let's just call it time date. It's a time and a date hybrid class. So now I'm a subclassing date. I'll show you the syntax in a few minutes. But if I do it this way, I don't have to change anything in the code. If I put NSObject down there, then I have to programmatically change it. So now I have time date up here. And in the .h file, I automatically imported date. And I'm automatically coming from date. So now I could actually make an instance of time date and run the same functionality that I did before, because I still have those methods and I still have it's just the same thing as Java, this inherited class, and I still have this going on here, import time date, which is the .h file that's going on in the .m file, and then now I can have implement. So actually out here I can switch date to time date. Out here I can switch. What is that message for anyway? Complete implementation. Date. I don't know what I left out. Anyway, I probably left something out. So, time date. And that's going to cause problems because I don't have an init for that. Let's go time date. Time date. Did I call it time date? I called it time dates. Well, it's not implemented. I don't have any code in there, so I don't necessarily want to make an instance, but I'll do it more formally with a better example on Wednesday. But essentially, if I created the full body for that, initialized it, and ran, well, what I have to do is it's kind of the same thing you do for Java, but instead of saying super, I'm going to go back. I'm going to run init on the date class so I can initialize that stuff. Otherwise, nothing's initialized. And it's going to complain because I can't initialize it when there's no initializer. But I can initialize date because date is from NSObject and it's running the superclasses initialize. And object, NSObject has an init method in it, which is why that's working. But we'll run through a formal example. But what I wanted to show you is that time date was extended from date, and this is where the inheritance comes into place. And theoretically, if we go through the full implementation, then we're going to get all of everything that's included in date plus stuff that is inside of time date that we added to it. We specialized it. So we have methods. We have method overloading also. So implement a new method with the same name as the one defined in the class farther up the hierarchy. The new method overrides the original, so instances of the class will perform the new method rather than the original one. So basically it's the same concept as Java. We're just creating new methods and we use the same name for the method, and all of a sudden now we have two declarations of the same thing. And so we can just, whatever object we are via the is-a relationship, it just is going to run. So that's why a lot of people use the ID, because it's generic. How do you know which level in the hierarchy you're going to go? Well, just assign it to the level that when you get there, and you don't have to worry about it, the reference type being like set in stone. Unless you know you're going to use it as a date, and then just leave it alone. So this is the class objects themselves that we're creating, the instances. We know we're defining the interface in the .h, and then we have the implementation in the .m. In C++, they call it the, specification and implementation. Like, I'm going to get terminology right here. So interface is really a specification, and sometimes referred to as that. Java doesn't have any of this. We don't have two files that go together in Java. We just have one .java class. Excuse me, one .java file that turns into a .class file. So the abstraction is we're going to break it out into two. Now that's kind of the funny thing. See, Java has interfaces. We implement interfaces. So we extend classes and we implement interfaces. Well, what is an interface? It's really a method. It's really a class. The interfaces that we were creating in Java were really classes without method bodies. They were just generic methods that didn't have any implementation to them, which is really the same thing as the interface here, but Objective-C's object-oriented implementation of it makes it so that each implementation is supposed to have an interface associated with it, which a lot of people would say, well, that's a lot of work. Well, wait until you see protocols. You can assign it a protocol, which is kind of similar to the concept of assigning it an interface. And I believe actually I ran through some protocol stuff with you guys about a couple of lectures ago. And let me tell you, after that, that's when I decided I need to show you guys Objective-C. Because I got some blank looks on everybody's faces, and I'm like, oh my god, this is terrible. So I'll go back and revisit protocols again, because I know you guys didn't catch any of that stuff. Let's talk about interfaces still. We actually have this, and this is really called a compiler directive. So anytime you see the @ symbol, you're talking to the compiler, which is kind of an interesting thing as well. Java, we don't have a compiler. Java, we go into intermediate code and we have a JVM, and the JVM manages everything for us. Same thing actually on the Android platform too, but in Objective-C we've got this directive. So the declaration of the class interface begins with the compiler directive, and that's where we get the @interface. Every string that you create will begin with a directive. @hello world, whatever it is you're creating. You're telling the compiler, this is an interface. Just the same way as when you go @hello world, this is a string. Which is kind of stupid, I think, actually. And it always ends with an end. Think of this like the opening and closing brackets of a function. It has to start with it has to end. If you put something past the end, you're going to get a compiler error. It's not going to compile for you. So here's the interface class name, calling it superclass. Instance variables are declared, and remember I said instance variables are inside of the opening and closing brackets. Everything else is outside. Think of this sort of like the private and the public sections of the class. So instance variables are always private, so they're inside of the opening and closing bracket, which they're enclosed inside of the class. These are open, They're public. So this is the way you're going to run the functionality on the class. We have declarations for the instance variables. We saw this actually. This is the same as C++, excuse me, as C++ and Java, except the NS color, which is similar to the NS string, which we're using essentially NS anything, is coming from Next Step, which is the operating system that the Coca developed from, which is essentially the definition of the type of variable. So the data type here, this one's going to be an NS color. We actually have to use that asterisk to say that that asterisk is basically a pointer. So it's funny, so these end up being pointers, but we never have to call them a pointer. Because we can do the addressive operator automatically on them, and they're built-in data types. All of our objects we have to create as pointers, which is kind of weird in terms of the oddities. So the methods of names of methods can be used with class objects. Here we have the class methods with the plus. alloc is a class method actually. If we were to create our own alloc, which we could, but why would we want to do that? We wouldn't want to do that. That's actually a plus. Proceed by a plus. And then the minus is this is going to be our instance methods. So most of what you're going to be doing is going to be a minus. It's always going to start out with a minus. And I'm thinking, well, why in the world have them in there then? Because, you know, no other language do. Well, you can use the keyword static in C++. Actually, static makes things class level in Java too. So pluses and minuses are mostly symbol based. Well, it's the same thing with the directive. It's a symbol, that @ symbol. It's going to be a, you know, just like the plus and the minus. It's going to be replacing keywords essentially. And then we have our import, as I mentioned before, just to catch up with what I showed you. The interface is usually included with the # import directive, which says import rectangle.h, import date.h, to reflect the fact that the class definition builds on the definition of the inherited classes. So interfaces will begin by importing the interface from its superclasses. So the interface itself will import it, and then the class will implement itself. So what am I saying? Well, I'm saying this. Date.h isn't importing anything, but time.h is going to import date.h, but time.m doesn't import it. So the interface imports the interface of its superclass, and then the implementation imports the interface of its own self, of its own class. So there's a lot of people that do this, and I see this a lot actually. There we go. Import date.h. That's unnecessary because it's already in here. And if you did includes, if these were include, oops, then you're going to get what's called you're going to have to use an indefinition with this, which you don't want to do. Now you have multiple includes actually. You should get a lovely little error message soon, as soon as I start doing this. No error message. Okay, good. Maybe it's smart enough to figure that out. Eventually you're going to run into a problem where you've included it multiple times and it doesn't know what to do with it. But that's a problem you usually get with C++. I wonder if this would run actually. This is kind of an interesting test. Build failed. Well, why did it fail? Duplicate interface definitions. Multiple includes. Slightly different error message, the same reason. Duplicate interface definitions for date. So in C++ you get multiple includes or something like that, I think it usually says. But well, so it's a lack of a better description, I guess. Interfaces is the right one. So
did PHP get the style of this?
PHP is very small talk like, yeah. Yeah. PHP.
Did you always include other files in your script?
Yeah, this is very C++ like, the includes. Which is very C-like, which is very PHP-like. PHP is just a variation of C in small talk. Yeah. In fact, the more you learn different languages, the more you see it's all the same language. I mean, the syntax is slightly different, but object orientation is object orientation. There's no, we don't need that. Oops, yeah, remove the reference. And then make this an import. There we go. Oh, no. Import time. Oops. Time date. Oh, wait a minute. This is the time. Yeah, here we go. I probably just messed that up. I did. Okay. Well, that's all right. We're not going to use. I removed it completely. Okay. I accidentally deleted it, so I'll remove it again. I took the time out. Okay. Anyway, let me finish up a couple more concepts and then I'll leave you with that. Otherwise, you're going to get information overload for one night. At class. So it refers to other classes. So if the interface mentions classes, so if I made an instance of date or I referred to date inside of another class that I was implementing, and it's not in the hierarchy, it must be declared with the at class declarative. Did we do that yet? We did that actually. We did that in the Objective-C class, and I haven't actually, well, maybe I did explain it back then, I'm not sure. But that's how you go out of the hierarchy. So if it's not in the inheritance and you want to include it in there and you want to build on it, but you're not inheriting from it, you go the at directive with the class name. So at class rectangle comma circle is going to include outside of the current hierarchy. Alright, so here's an implementation example, importing a classname.h. This is the implementation. This is the classname.m file, where we have the implementation of this class. We have some method definitions here, and then we're going to make identical twin. So we have a method. It's an instance method. And if it's a twin, then sibling alloc in it. And then now we see, well, this is very C-like as well. So people who are in the Java course have never seen this syntax before. And you can actually get away with not using it in Objective-C. You don't actually, depending upon how you're using your object references. If you're going to set, and this is really the wrong way of doing it, but if you're going to set without using, make this public, and you're going to set the gender to equal a gender, you're going to set, this would be actually inside of the class implementation. This would not be in main. So this is in the implementation file. But twin.gender, twin.appearance is equal to appearance. And you're basically calling instance variables that are part of members of the class, and you're using the dot notation, but you're using an arrow, this kind of syntax, because this is a pointer. So those people who've had C understand what that means. Those people who have Java probably never saw that before. So here's an NS object. Here's a worker who's a interface worker who's inherited from an S object. He has a character name. We create a pointer. This is equivalent to a string, actually. Now we're using private and protected and public. Well, this is very C-like. It's actually C++-like. So it's a combination. So here's the implementation. Promote to new position. This is a method that takes on one parameter, and one parameter is called new position. So ID old is equal to job, job is equal to new position, return old kind of thing. So it's basically just playing around with a method called to promote that takes on a new position, which is going to be an integer value probably. If the it's not even in here. Okay. Evaluations in here, jobs in here, wages in here. Okay.
It doesn't have to be a specific type.
It does, and it wasn't declared. I was looking to see if it was, excuse me, no, this is not. This is used in here. This is shortcutted. It should have a type next to it, yeah. The function, if it's returning something, which it is, it should be of an integer type. So it's a really bad example, actually. So we can actually use GCC to compile this Objective-C code, which is why a lot of people install actually GNU setup if they don't have a MacBook. And but you can't do iPhone and iPad development. You can put in CGN or like a Linux virtual machine, virtual kind of kernel, load it up. CGY, I think it's called CGWin or something. Anyway, long story short, and then install GNU setup in there. This little plugin that you can put in there, and you can actually install and use GCC with that. And then you're compiling with GCC. So the Xcode compiler is actually a GNU GCC compatible compiler, which is why in Xcode you can write C++ code, you can write C code, you can write Objective-C code. In your iPhone applications, you can actually write C code, which is kind of interesting. But you're kind of going to be limited to a certain point because C code is generally not sufficient enough to get you through most of the object stuff that you have to create, because you can't create objects with C. So if you've got integer I, well, that's C. Printf, scanf, well, that's C. But how many times you're going to be using that in an iPhone application? Not too many times. It's like command line stuff. But it's actually kind of interesting to know that it does come. So, and the pre-installed also have iPhone Simulator for Xcode IDEs. You know that already. So if you were going to take the Windows route to it, although you can't get the iPhone iPad interface to work with it, you could install Ubuntu, run it from Linux, and dual boot your system. You can't really do this from Windows. You actually have to like install something on top of Windows, or as a virtual machine, or a dual boot system. Ubuntu is actually kind of good for that. Install GNU Setup. It's a free clone of Coca, and then you're gonna go through all these steps to install it. There is a version that runs on Windows, but it's in a Linux shell. So it actually loads up a Linux kernel, which takes about 5 minutes. And then it loads up to GNU libraries on top of that, which takes another 5 minutes. So that's why I say don't count on this like as a development technique. But it does actually work. People have spent a lot of time creating tools for it. Still doesn't support still does not support iPhone, iPad APIs, which is kind of impossible to install. Alright, how are we doing on time? 8:33, you guys want more? Or you have information overload? I can go on. Okay, I'll let you out early, only because this is a really good stopping point. Because then when I have to show you more source code stuff, I don't want to like cut it. So someone can remind me, I stopped on slide 24. 24 for Wednesday.
Yes.
Otherwise I'm going to forget. We'll finally get out early because I've been letting you guys out like another 15-20 minutes from now normally. So today we'll give you a break for those people who showed up. So sign the roster if you have not signed it already. What happened to it? Oh, it's back there. Okay, good. Unless we have any questions, comments, or concerns, we're done for today.